This episode where we are going to discuss a cuboid, which is under three-dimensional geometry, and with me is an example of a cuboid. Now, we are going to look at, first of all, the features of a cuboid. Now, a cuboid, if you are to draw this cuboid, a cuboid, first of all, it is made up of rectangles. This one is a rectangle, this is another rectangle, this is another rectangle, this is another rectangle, this is another rectangle, and this one is another rectangle. Now, meaning that if the cuboid is made up of rectangles, you can best draw it like this. We first draw the first rectangle, then we can have something like this, and have something like this. And then we produce this one here, we produce this one here, we produce this one here, and then we produce this one here. This one, you can show it when it is dotted, because ideally we cannot see it. So this is our cuboid. This is our cuboid, and from the way it is, it is like this. This face is this face. This top is the top here, this one is the same as here, the one behind is this one here, this one is this one, and then the bottom is this one here. Now the properties of a cuboid, we have said it is made up of rectangles. And remember, this is an angle of 90 degrees, this is also another angle of 90 degrees, and so forth. Now still, we should know that where the cuboid is sitting, it is what we are calling the base. And we shall always be calling it the base of the cuboid. Now, we should clearly know that for a cuboid, two opposite faces, this one is a face, this one is another face, this is another face, and this is another face, this is another face, this is another face. Now, we should clearly, and we shall get to know that a face is also a plane. So, two opposite faces are the same for a cuboid. This face is opposite to this one, they are the same. This face is opposite to this one here, they are the same. This top here is opposite to this one here, they are the same. So two opposite faces of a cuboid are the same. Now, we should now clearly see that for this face, this is the length, this is the height. So we are having the length of the cuboid, then this one is our height h, then this one is our width of the cuboid. So it has a length, width, and then height. Now we may be asked for the volume of a cuboid. We may be asked for the volume of a cuboid. But we may have two cases of cuboids. We have a closed cuboid and we have an open cuboid. For example, the cuboid that I have is closed. All the faces are closed. This is closed, all the faces are closed. Now, if you ask for the volume of a cuboid is length times width times height. And remember, the volume is always in cubic units. The volume is always in cubic units. Still, we may be asked for what we are calling the total surface area. Total surface area of a cuboid. But we are going to look at two cases. The first case is when the cuboid is totally closed. There is no open end. There is no open face. So it means total surface area means we are going to look for the areas of all the surfaces. So we are going to look for a closed one. Total surface area of a closed one. So we have said the length, the height, the width here. But we said two opposite faces are equal. It means if this is the length, also this one here is the length. This one is the width, also this one is the width. This one and this one is the width. This one and this one is the length, also this one is also the length. Then this is the width, this is also the width. If this is the height, this is the height, this is the height, this is also the height. Now we want to find the total surface area of a closed cuboid. Now, total surface area. The first area will be this one. Remember, this one has length, this one has the height. But say this one is similar to this, meaning that it will be 2 times getting the length times the height. So this will be 2 into L times H. The length times the height. Remember, this is a rectangle, and the rectangle area will be length times height, but this one is the same as this. So that's why you're having 2 into L times H. Plus, now this one is same as the one behind here. So if this one has the width, it has the height. But there are 2. This one is similar to the one behind here. So we shall have 2 into W times H. Then plus. We are left with the top and the bottom. Remember, the top has a length, it also has the width. So meaning that we are going to have, and remember this one is the same as this. So we are going to have 2 into length times width. When we substitute the measurements of length, width, and height, we shall get the total surface area of a closed cuboid. But what if we have an open cuboid? What if we have an open cuboid like this one? What if we have an open cuboid like this one? That one means that we are going to get the areas of all the surfaces, but this the top is going to be not inclusive. It's going to be left out. Meaning that we have to first find this one, find this, find this, find this, and also find the base. So you're now going to find total surface area of a cuboid with the top open. So I say total surface area will be, the first one will be this one, length times height, but this one the same as this, so meaning there are 2, so it will be 2 into length times height plus. We're also finding that now we're having this width times height, the same as the one behind here, so it will be 2 into the width times height, but now the top is not there, so we shall find this one which has the width and then the length. So we shall say plus just the length times width. When we substitute, we shall get what we call the total surface area of a cuboid. So that's how we get the total surface area of a cuboid. That's how we get the volume of a cuboid. Volume of a cuboid is length times width times height. The volume is in cubic units, while the area is in square units. Now, we should also remember that whenever we ask for capacity, capacity is related to volume. Capacity is related to volume. Remember, the SI for capacity is liters, while for volume it is cubic units. And we should remember the conversion. That 1 liter is 1,000 cubic centimeters. Please remember, if you are to convert from cubic centimeters to liters, that is the relation there. So if a question is asked for, if a question is asked, calculate the capacity, please get the volume. After getting the volume, convert it to liters. Thank you for watching. I remain Agaba Jared, and thanks for subscribing. Please subscribe to my YouTube channel, Agaba Math, where we deal with O and A level mathematics. Thank you very much.